Okay, so yesterday we looked at characteristics of your quadratic functions. We also then learned how, or we refreshed our memory on how to graph them using transformations. And then we also learned that very, very, very tedious way of graphing parabolas, aka quadratic functions, from Algebra 2, doing all of the opposite of b over 2a, xy chart. But today, I'm going to show you, I think we all agree that it's so much faster for us to graph quadratic functions when we can see their transformations. It's so much faster. So, good news, I'm going to show you how to take a function in standard form. Remember, standard form, we talk about this, the ax squared plus bx plus c. I'm going to show you today how to take an equation that's in standard form, just like the Alg 2 one we did yesterday. I'm going to show you how to transform it to what we call vertex form so you can see your transformations and graph it a lot quicker. If you need to, before you go any further in this video, if you need to revisit how to complete the square, you should find that video on how to complete the square and refresh your memory, because that is what we are going to do in order to put our functions into vertex form. So take a look. Letter A, letter B. If you see them, look at them. They are in standard form. I don't see any of my transformations. The only thing that I see by looking at them is my y-intercept. I know in letter A, my y-intercept is 22. In letter B, my y-intercept is 10. That's all the information that I see. So what I'm going to show you is how to use completing the square to put things into vertex form. Okay, so completing the square. If you take a look, the first thing I'm going to do, I'm going to group those first two terms. I know that my first step in completing the square is usually to take that 22 and move it to the other side, but I don't have two sides in this problem. I only have a function. It's not equal to 0, so I'm not solving anything. So what I need to do is, instead of move that 22 to the other side, because there is no other side, what I'm going to do is I'm just going to group those first two terms, and I'm going to leave that positive 22 where it is. So after I group those first two terms, now I'm going to complete the square. Same process. I take half of the middle term and square it. Half of negative 10 is negative 5, and I square that. When I do that, what I get is x squared minus 10x. There is the line that I completed the square. I got plus 25. All right, here's where the tricky part comes in. I know I still have this 22 there, so I'm going to leave that where it is. But here is where it changes a little bit. I know when we completed the square the first time, whatever I did to one side, I had to do to the other side in order to keep it balanced. That is the key word that I hope you're getting out of my voice. We have to keep it balanced. So think about it. There is not two sides to this equation. There's only one side. So right now I've tipped it. I've added a positive 25 to the right side, because think about the equal sign that's there. What I've done is, here's my equal sign. I've added a positive 25, so I've tipped the scale positive 25. Well, because I have to keep it balanced, I know what should go on that line there is negative 25. Now it went from tipping it to positive 25 back to balancing it out. So 25 and negative 25 would cancel each other out. Here's what I want you to think about, and I know you're going to have to take lots and lots of notes on this. Think about if I were to combine like terms in this problem. I know my like terms would be here, here, and here. If I were to combine those like terms, notice that what would happen is I would get my original function back. If I had a positive 25 here instead of a negative 25 and I combined my like terms, would I get my original function back? Hopefully you're saying, no, you wouldn't. You'd be adding 50 and 22, so it would actually become plus 72 instead of plus 22. So that's the way you can always check yourself. Make sure that it stays balanced. You should be able to simplify it and get the original function back. If you're with me so far, that was the hardest part about doing this. Now what I'm going to do, complete the square just like I've always done. What's in parentheses, I believe I can factor that now. So I get x squared, or x minus 5 squared. I combine my like terms that were right here. I combine those like terms to get negative 3, and voila, there is your vertex form. Look at how much easier that is going to be if I were to ask you to graph that. So there is vertex form. I ask you to look at the directions, then state the transformation used to obtain the graph. Think about your transformations. What are they? Well, you should be saying that my transformations, first one is a horizontal shift right 5. Second one would be a vertical shift down 3. So if I asked you to graph this function, now you'd be able to graph it no time. Next, identify the vertex. Okay, so my vertex, I want you to think about that. My vertex is going to be the 0.5 comma negative 3. Think about your transformations. Right 5, down 3. Your vertex is 5 comma negative 3. I'm going to give you some great advice. Take a look at your vertex form. There is your 5. There is your negative 3. Think about your transformation. So that's why they call it vertex form. Ta-da, you can see the vertex in the problem. Okay, so understand vertex form. You can obviously see the vertex. Okay, so next, I asked you to find all intercepts. Let's start with the y-intercept. That one's the easy one. I know the y-intercept is that point 0 comma 22. Be careful, your y-intercept has to come from standard form. There it is, standard form. Don't make the mistake that I see every single year. I see students, they want to use this number right here as their y-intercept. Remember, it always needs to be in standard form. That's the way that you can see your y-intercept. I'll talk to you about how you can find it in vertex form tomorrow. Okay, so then next, let's find our x-intercepts. The way that I'm going to find my x-intercepts, well, I kind of gave it away already. The way I'm going to find my x-intercepts is to use my graphing calculator. I know the x-intercepts are my zeros. So in order to find my zeros, the quickest way you can do that, use your program. Use your QF program. You know that in this one, a is 1. Look at your original function. A is 1. B is negative 10. C is positive 22. Practice your QF program. Plug those numbers in. Do you get 6.73 and 3.27? Okay, you should have got those. Be careful. I'm going to be very, very picky about this. Your y-intercept and your x-intercepts, they should be written as points. Do not just simply put the number. Make sure you always write them as points. And ta-da, you have just learned everything about vertex form. So, let's take a look. Let's do another one. Letter B. All right, so vertex form. I know the first thing I'm going to do. I'm going to group those first two. I'm then going to take half of the middle term. Half of 8 is 4. Square that. There, I'm starting to complete the square. So I have x squared plus 8x plus 16. 4 squared is positive 16. So inside I have positive 16. Think about your next step. I have plus 10. Come on. What number needs to go on that line that I have there? Hopefully you're saying to yourself, you should have negative 16. You have to keep that equation balanced. I've introduced a positive 16 to the right, so I have to undo that to keep it balanced. Complete the square from here. Combine your like terms. Voila, there's your vertex form. Okay, next, your transformations. Okay, that should be pretty simple. Your vertex, negative 4, negative 6. Think vertex form. There it is. There it is. Right, so don't forget that. Y-intercept 0, 10. Think there is the 10. There is your y-intercept. X-intercepts, obviously what we're going to do is use our QF program. And there they are. Alright, I want you to try... Nope, not yet. Let's do one more together. Letter C, this is where it gets a little bit trickier because I have that negative out front. So, think about it. Again, same deal. Let's group those first two. With the grouping of those first two, hopefully you remember to factor out that negative. If I factor out the negative, the signs change. Think I'm just going to leave that negative 19 where it is. Alright, so half of the middle term and square it. Alright, so there is my positive 25. Okay, here is where I'm going to lose the majority of you. And I think, hopefully, you're paying attention. I want you to think about why I'm about to do what I'm going to do. Uh-oh. Why did I make that the same as what's in the parentheses? I don't get it. I'm confused. You told me that it had to be the opposite, and now you're telling me it has to be the same. Why is it the same? Any ideas? Well, I'll give you a hint. If you think about it, it's the same because what I've done is I've technically introduced a negative 25. If I distribute that negative, I've technically introduced a negative 25. So to undo that, I have to make it a positive 25. So, good news. Nothing has changed. You still have to undo it. Just please don't forget about that negative out there. And then from here, pretty much same deal. Vertex form, keep that negative out front, factor it. Negative 19 plus 25 is positive 6. Oh, now you should understand why that negative is so important to keep out there. Think about your transformations. I got a right 5. Oh, that negative outside. I can't forget that because that's my reflect x. And then I got a vertical shift up 6. So, vertex, same deal, 5, 6. Y-intercept, 0, negative 19. QF program to find your x-intercepts, and voila. So, letter D, on your own, try it now. See what you can do. Start to finish. Ready, go. Alright, so, quickly, through this. Group those first two. Half of the middle term, square it. Positive 9. Okay, undo that. Negative 9. Factor. There is your vertex form. Transformations. vertex, y-intercept, x-intercepts, and hopefully you made it through that. Hopefully. So think about it. I just taught you much faster way to graph quadratic functions instead of that old school alg 2 way. Let's go the new school alg 3 way. Let's change those into, we're going to complete the square, change them into vertex form so we can see our transformations, and voila.